This type of question you might see on the SAT or the ACT, or really any standardized math test that involves algebra and word problems. So regardless of the test, go ahead and try this question. Before I give you the answer and work through the solution, I want to do something a little bit different, and that's focus on a mistake that many students make when doing a question like this, when translating this word problem into algebra and then solving it. So what I want to do first is show you a way that many students tackle this question, and perhaps some of you watching this video did it in exactly this way. And then what I want you to do is, after I walk through this pseudo explanation, I want you to take a few minutes and think about what mistake did I make when I was doing it this way. So this is the wrong way to do it. So you may yourself have done it this way, and if you see the way I do it is exactly what you did, then you have to think, okay, what mistake did I make? But if you didn't do this, if you did it a different way and got a different answer, I want you to also think, what mistake did I make in this procedure? So Laura has to submit a portfolio of art as part of her application to art school. She can submit sculptures, drawings, and paintings as part of this portfolio. If she submits twice as many drawings as paintings and 3 times as many sculptures as drawings, and if she submits 45 total pieces of art, how many paintings did she submit? So we need to translate this word problem into equations which we can solve. Let's define our variables here. Let's do D as the drawings. We'll do P as paintings, and S is sculptures. So now we need to set up our equations here. So the first one, let's see. She submits twice as many drawings as paintings. So how am I going to translate that? Well, it's twice as many drawings as paintings, so that would be 2D equals P. Next, 3 times as many sculptures as drawings. So that would be 3 times S, because S is the sculptures, and that would equal the drawings as well, right? Just translating our words into equations. So now we have these 2 equations, but we also know that the drawings plus the paintings plus the sculptures should equal 45. And until I get this in terms of one variable, I can't solve this. But luckily, I have these equations which I can use to substitute in our main equation here. So let's see, we're solving for paintings. So let's get this all in terms of P, I guess, right? We're solving for paintings. So we're going to leave this P the same. 2D equals P, so that means D is P over 2. So I'm going to make that substitution here. And since D is P over 2, that would mean 3S is P over 2, which would mean S is P over 6. So I'm going to write P over 6. So making those substitutions, I get this all in terms of P. Now I need to solve this equation. Let me multiply both sides of this equation by 6, and let me actually get my calculator out here, though I probably don't. No, whatever. So multiply both sides of this by 6, and 3P plus 6P plus P equals 45 times 6, 270. Whoops. So I got 10P is 270, or P is 27. If you got that as the answer, unfortunately, this is wrong. So remember, everything I just did, or part of what I just did, is wrong. It's a mistake, and it's a common mistake that many students make. So if you got this error, if you got this answer, you made this mistake. So definitely take a minute to try to figure out what the error was. But let's say you got something different. You did this problem a different way. Try to figure out, take a look at my math, and figure out what mistake did I make. So pause the video and work on that. Did you find the mistake? Well, I'll walk through the mistake right now. The mistake is in this portion of the work. We translated the words pretty much directly from the text into equations, and that often can work. But when you're doing that with multiple variables, as we are here, D, P, and S, simply translating directly as the words present themselves to you actually ends up getting you the wrong answer. And if you think about it for a second, it actually makes sense why. So we have twice as many drawings as paintings. So it seems like at first 2D equals P would make sense. But think about it. Let's say we had 20 drawings. how many paintings would we have? Well, if we have twice as many drawings as paintings, we would have 10 paintings, right? Makes sense, double the amount of paintings. Notice if I plug these values into this equation, I get something that doesn't make sense. 2 times 20, which is 40, equals 10. That doesn't work, right? It actually should be D equals 2P, because now 20 equals 2 times 10. So the issue when you're translating, you cannot simply translate as you see it. You have to realize, okay, wait a minute. If there are twice as many drawings as paintings, then in order to set them equal, in order for the number of drawings and the number of paintings to be equal, I would need to double the number of paintings. So that would be equal to the number of drawings, of which there are 2 times as many as paintings. Right? It's a bit confusing to think about, but if you plug in numbers, it makes more sense. So really our equation should be, if we scroll down, D equals 2P. That is our actual equation, because now we see, okay, however many paintings there are, and there are, let's say, P paintings, we have twice as many of those that are drawings. So that's why we double the P to get our D. Same thing's going to be true with 3S equals D. So here, again, we translated word for word. But again, if I had, let's say, S equals 10, if I had, this is 30, let's say I had 30 sculptures, how many drawings would I have? I'd have 10, because I've got 3 times as many sculptures as drawings. And if I look at 3S equals D, that's not going to make any sense. 3 times 30 is 90. 90 equals 10? No. It should be, as you might expect, D equals, or S equals 3D, right? For the number of drawings I have, D, I'm going to have 3 times as many sculptures, so I need to triple the number of drawings for it to be equal to the number of sculptures. So these are the 2 equations we need, in addition to this, which is correct. The sum of them has got to be 45. And now I proceed as we did before. Make a substitution, go from there. So again, we're going to substitute for P. D is equal to 2P, so I'm just going to call that 2P. P is still P. Now S, notice S is 3D, and since S is 3D and D is 2P, I can just make that substitution here, and I will get that S is equal to 6P. So when I add these up, I get 9P is 45, and P is equal to 5. And that would be your answer. So what's the lesson from this? Well, the first lesson is be very careful if you're going to use multiple variables translating this. Take a second, just double check the equations, plug in numbers just to make sure it makes sense so that you don't mess up this relationship, because it will get you the wrong answer, as we saw here. Perhaps the more important lesson, though, is we can avoid this issue altogether if we actually use one variable. The instinct here is to go to multiple variables because we have multiple things, drawings, paintings, sculptures, so we think, oh, DPS, okay, fine. But it's actually easier to use one variable in most cases. And so how would we do that? Well, when we use one variable, we have to define our variable, we'll call it X, very carefully. And the trick is usually you want to define the X as the value that is the smallest value of whatever the sets of values that you're looking at are. So here, if there are twice as many drawings as paintings and 3 times as many sculptures as drawings, that means the paintings, that they're the fewest amount of paintings out of this set, because there's double the amount of drawings as paintings and then triple the amount of sculptures as drawings. So we're going to define our variable. So let X equal the paintings. Now, as it turns out, it really doesn't matter what you define your variable. You can define X as sculptures, you can define X as drawings, it's all fine. It's just easier to solve the problem generally if you define the variable this way. But no matter how you define it, you have to be very careful and precise. So if X is the paintings, if she submits twice as many drawings as paintings, what do you think we would make drawings? Now, in terms of X, we don't want to make it a different variable. What would it be in terms of X? Well, it's twice as many drawings as paintings, and if there are X paintings, we're going to do 2X drawings. Now, what about our sculptures? Now, there are 3 times as many sculptures as drawings. So if I have 2X drawings and I have 3 times as many sculptures as drawings, it's just going to be 3 times 2X, or 6X for the sculptures. So now notice we have all of our terms in terms of X, so one variable. And again, when we add up the paintings, the drawings, and the sculptures, it should equal 45. Note that this is exactly the same equation that we got above, except here we're using X's, before we used P's. So the difference is, in this way, we had to go through that intervening step of making substitutions. We had to go through that process of dealing with the ordering of how you write the equations in the first place. Lots of places to make errors. So really, the best way to go is just start right with your single variable, because at this point, we'll get 9x is 45, and so we get x is 5. And if you look at our legend, or little key, x is the number of paintings, so our answer here, again, is 5. So that's the lesson from this. Be very, very careful when you're dealing with multiple variables, when you're translating. Sometimes it's a lot easier to, or a lot more direct, and less chance to make a mistake if you use one variable. So I recommend trying one variable first whenever you can. To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.